Good afternoon student. So today we are going to perform experiment on linear variable differential transducer. So this is the setup for the linear variable transducer. Now first of all we will see the block diagram of this linear variable transducer. So as we have seen in our theoretical lecture, there is one primary winding to which voltage supply is given, and there are two secondary windings of equal number of turns are there. So this is the setup for the LVDT, linear variable transducer. Here we can see that in between, here it is the primary winding, and above which there are two secondary windings are there. In between there is one armature is there. With this knob it moves. If you are noticing, it moves on another any side, whichwhere you want. If you want to move it on right, it will move it on right. If you want to move it on left, it will move it on left. Okay. So now it is when it is at 0th position, that is it is exactly under the in between the both the secondary windings, then you can see that the output voltage, it is in millivolt, is 0. Okay. So now we will try to move this winding or this armature on any one of the side. So as soon as we start moving it on the right side, on this side, right side, then you can see that the voltage now starts developing. So now we will move nearly 0.5 millimeter on the right, and then we will note down the reading. So now if you are able to visualize it, this is the 0.5 mark, this is 0, this is 0.5, and this is, we have matched it with 0.5. So if we move the rod by 0.5, then there is voltage generation of 16.7 millivolt. Okay. So this is our first reading. Displacement is 0.5 millimeter and output is, displacement is 5 millimeter and output is 16.6 millivolt. Now we will move it to 1 centimeter or 10 millimeter. Here now you can see that we have matched it with 1 millimeter. Okay. So now corresponding reading is 31 millivolt. Okay. So similarly we have to take the readings. Further we will move it to 1.5 centimeter or 15 millimeter. Now we have matched it to 1.5. Okay, centimeter. So corresponding voltage is 46.1 millivolt. So similarly you have to take the reading. Now we will move this rod to the left side. Now this side we will move to it this side. So we will see that the voltage generation will be negative. That is, voltage generated in the primary winding is less, first S1 secondary winding is less than S2 secondary winding. Now it is now 0.5. It is now 0.5 millimeter, but it is on opposite side. Okay. Corresponding voltage is 11.3 millivolt. Okay. Now we will move to it now to 1 centimeter or 10 millimeter, and we can note down the corresponding reading. If you are able to visualize it, it is now it has matched with 1 centimeter and corresponding voltage is 26.2 millivolt. So similarly we have to take the readings and we have to plot a graph like this of voltage versus displacement. So here this LVDT, that is linear variable differential transducer, is converting this displacement, physical quantities displacement, into electrical quantity, that is volt. Okay, voltage. So this is our experiment. Thank you.